Welcome back to another video on the channel. In today's video, we're going to be taking a look at 2021's QCAA exam paper 1 question 3, and we'll just be going how to solve this question individually today. Now, as you would have known, I've started splitting up all the questions into their own videos. This is pretty much because if someone only needs help with some questions, they can go to those exact videos rather than going through the entire exam video. Now, the entire exam video is still up on YouTube. The link is in the description below. I've also made a custom methods exam bundle that's in the link in the description below. So if you need any additional resources, check that out as well. But otherwise, let's get straight into this question. So this question here, I would say, is pretty easy, okay? Now, I'm going to be showing you two ways to solve it. One very fast way and one systematic way here. So here, we're determining the integral of 10 e to the 4x dx. Now, the integral of e to the x by itself is just e to the x by itself plus c. Now, there will be a property of that is maintained here. However, it won't be exactly the same because there's a 4 up here, okay? So, I'll show you the fast way to do it, and then I'll show you a systematic way to do it as well, okay? So, when you're doing this guy here, what I would do first is take the 10 outside the integral, just to make it a bit easier to look at. That way you don't have to worry about the 10 until a bit later. So here, when we're integrating e to the power of 4x, what you have to do is just divide by the derivative of the inside function. So this would be the inside function here. So the derivative of 4x would be 4. So here, to integrate it, we just go e to the 4x, divide by 4, times by that 10, and then that plus c there, okay? Multiply that 10 outwards there. 10 times by c is still going to be a constant, so that won't affect it. Then you have 10e 4x over 4 plus c. 10 over 4 has a common factor, highest common factor of 2, so that's the same as 5 over 2. So here your final answer would be 5 over 2 e 4x plus c, and then we check which answer is correct here, okay? So c would be the correct answer. Ones that are definitely incorrect. This one should be 100% incorrect, okay? Because they've added 1 to the power divided by the new power. They've used this rule here in that case there. Now, I'm going to show you a systematic way as well to do this here if you're not convinced with the fast method, okay? Which a lot of people aren't usually. So, I'll be showing you another way to handle it, doing a u substitution. Now, u substitution should be taught to everyone, in my opinion. It works every single time, okay? So, our goal is to transform it into an easier integral. So what we do is we let u equal your inside function or the biggest algebraic expression. So here 4x would be u. What we then want to do is if we were to substitute this in right now, so if I were to replace that in there, I would have this as an integral. The integral of 10e to the u dx, which doesn't make any sense at all because I have two variables now. I need to somehow replace this dx with a du while getting rid of that dx pretty much. So to do that, we're actually going to differentiate u to get an expression for du over dx. So if I were to differentiate this, I get du over dx equals 4. Now a lot of people don't know this, but this is actually a fraction here. You can move the dx to the other side and you can move the du as well. However, what you cannot do is you cannot cancel the d's here, okay? They are not separate variables on their own. The d is attached to the u, just like the d is attached to the x there. So here, if I want to get the dx by itself, I'm going to multiply both sides by dx. So I'll get du equals 4 dx. Then, to get the dx by itself, I'm going to divide both sides by 4. So I get du over 4 is equal to dx. Alright, now I'm going to get rid of this working here. That will have a bit more room. So, if I were to substitute this information in now, so if I were to replace this for that, and the yellow for the u, this is exactly what I would get. The integral 10e to the u du over 4. I can now take the numbers outside the integral, so I can take that 10 out the front and that quarter as well at the front. So I have 10 over 4 integral e to the u du, okay? So here, if I'm integrating e to the x dx, that would just be e to the x plus c. This is the same thing except it's u. So I've got 10 over 4 e to the u plus c. Then I can just put the 4x back into it. So here you would just chuck this back in and you would get the exact same answer as us. So 10 over 4 e to the 4x plus c, and we know 10 over 4 turns into 5 over 2. And you get the same answer, which is C. Now, is this method faster? It is faster once you're used to it. At the moment, you're probably thinking this is actually slower than the other method. Well, no, it isn't, because I'm explaining each step. Realistically, this should only take a couple seconds to actually write out when you're very familiar with it. If you've got this question wrong, you've got a lot of work to do though, okay? Because this would be a very easy question, okay? If you need any other videos, link is in the description for the full exam video. If you check out my channel, there will be other questions just like this one up there for each external exam. If you need an exam pack bundle, the link is in the description below. Go check that out. Otherwise, I'll see you in the next video.